Welcome to Embedded. I am Alicia White, alongside Christopher White. Our guest this week is Sarah Withee, and we're going to talk about programming languages and pancreases.
Hi, Sarah. Welcome to the show.
Hi, thanks for having me today.
Could you tell us about yourself as if we met at She's Geeky or some other technical event?
Yeah, I like to use the term polyglot software engineer just because I do software engineering stuff, but I tend not to stick in one language. So like work right now is in Python. I do stuff on the side with the robotics group in Java. I tinker on hardware things in C++. The tech community space has some management software that's in Ruby. So I don't really stick with anything in particular. I also mentor an all-girls robotics team here in Pittsburgh and can be briefly seen speaking at conferences once in a while and sometimes other places.
All right. We want to do lightning round where we ask you short questions and we want short answers. And if we're behaving ourselves, we won't say, "Are you really sure about Rust?" or anything like that.
All right.
What's with Rust lately?
It came up in class, and so it's on my mind.
What is your favorite kind of M&M? Past, present, or I will add, future?
Oh, wow. I'm terrible at predicting the future, so I don't know if I'll go there. But I do like the crispy M&Ms and also the ones with peanuts. Or not peanuts, pretzels in them. I do like peanuts, but pretzels are like better.
I didn't know there were other kinds besides the regular and peanut kind. So now I feel like
Whole world is open.
I need to have an M&M tasting.
Do you have a favorite video game?
Ooh. I'm playing lots of Splatoon lately, so Splatoon through 2 and 3. I do love the Legend of Zelda games too.
Favorite programming language for quick little tasks?
Quick little tasks. Maybe Python.
If you were a burglar and could only steal something that would cause inconvenience, what would it be?
Oh, I think I asked one of those on my Twitter question of the day once. Mm-hmm. Shoot. I'm like looking around my house right now, trying to think like, what would I do? Maybe take all the light bulbs.
How many languages do you think most software engineers know?
No, as in like could sit down right now and write some bit of code in?
Yeah, let's go with that.
Yeah.
Okay. I don't know. 2, maybe? I would average guess.
Do you have a favorite fictional robot?
I was thinking about this earlier because I think I saw this as one of the prompts. I'm really amused by Marvin the Depressed Robot from Hitchhiker's Guide. Not because he's necessarily like a really good robot, but I just appreciate sarcasm really well.
All right.
And Marvin's like particularly sarcastic on a regular basis. So,
if you could teach a college course, what would you want to teach?
Oh gosh, I saw that one and I couldn't quite think of a good answer. I think I was going to go like something completely not tech related and just be random. It might be like soap making because it's kind of interesting.
So I saw that you've given a couple of talks about pancreases.
Yes.
Pancreasi, Pegasus. No. One of which was a very short Bang Bang Con talk, which was pretty good, and I wanted to know more.
Yeah. So I have an artificial pancreas. And the reason I have an artificial pancreas is because I'm a type 1 diabetic. So basically, my body, for whatever reason, we don't really know why, it just stopped making insulin for things. And so I do need insulin on a daily basis, the 24/7 stream, insulin pump, all those good things. But I also have an artificial pancreas. And this little device talks to my insulin pump and also talks to a glucose sensor that's on me and tries to do some algorithms to figure out like what's happening with my blood sugar at any given moment, and then automatically adjust to give me more or less insulin at any given moment, depending on, if I'm starting to look like I'm going to go low or if I'm going to go too high, it will autocorrect for those things.
Is this like, it sounds like a rice cooker with fuzzy logic. You want it to go just the right amount.
Yeah. So you measure it in like milligrams per deciliter, and there's like the magic numbers. Like normal people, you keep it between 70 and 100 automatically with your own body. Diabetics are usually told to like keep it under 180 and above like 80 or something, just to be on the safe side. So my pancreas, kind of sees what's happening. Like if it's just climbing up, it's like, oh, hey, you probably ate something or something's going on that's making your blood sugar rise. We need to counteract that. So we give you insulin to bring it back down. If I start to go like trending downward, like I'm 100 and I'm like falling 5 points every several minutes, then it's just like, oh, bad things are going to happen in the near future. So it actually cuts off my insulin supply to try and save me from ever actually reaching the low. So it does a lot of auto magic to try and keep me in this like magical range that I can kind of define for it.
But that's just software. Why isn't that attached to the pump or to the glucose monitor?
Good question. So it kind of depends where you're looking. In the beginning, insulin pumps were, when we think of like smart devices, it's actually kind of a dumb device. Like you can, if you ate, you would have to pull out the device and kind of say, oh, give me so much insulin because I ate this much carbs. And the glucose sensor will tell you the values of what your blood sugar is right now. But both of these are kind of independent devices. So a bunch of people got together, figured out how to reverse engineer certain pumps and then certain glucose sensors. And then they wrote some scripts to kind of like make them talk to each other essentially through a separate device. And over time, what's been kind of interesting is the medical device companies have just kind of avoided it. Like, we don't want to touch this automated stuff, but they've started to see like all these open source hackery people, like tinkering with things and actually getting even better than their own products are. And so they've slowly had to actually like kind of change their pace. Like, oh, hey, wait a minute. We might actually have to start implementing some of this. So in the past couple of years, Medtronic, Tandem, is there another one? I don't remember off the top of my head. But they've started to release some of their own algorithms inside their devices. Tandem is good. A friend of mine runs it. She really likes it. I've met people that have had the Medtronic one and they absolutely hate it. They said they would rather go back to like older pumps that have been cracked and use the open pancreas systems.
I can understand from a medical device perspective why reading a value and being told a value, those are both safe. Somebody else has to take responsibility if anything messes up. But as soon as you connect them and make an algorithm that isn't just a above this you do that and below this you do that. It's a real, you have to be smart about it algorithm. That now is taking responsibility and makes you liable if it doesn't work for any one person.
Yeah. And that's why, like, that's the excuse they've tended to use. It's expensive. You got to do a bunch of studies. It's complicated. It's weird. It's hard. But at the same time, like, the open source people have been kind of testing it on themselves. And there's a blood test you can do. It's called an A1C. But basically, the percentage tells you essentially like how close in range your blood sugar values have been for the last 3 months. And they found this range is actually a lot better for people that are on these open pancreas systems than it is for people either doing themselves manually, which is usually like not very good at all, or the ones done by the med tech companies. And they're better, but the open source ones have been like really, really, really good. The people that developed the original algorithms, they actually have like white papers on them. You can go read these papers, how they've did these studies, how they've looked at past blood sugar values and then calculated like what the algorithm should be, and then just tested it on themselves, which is totally a thing you can do because you're not involving extra companies and you're not doing wide scale research. You're just kind of doing it to yourself. So that's fine. And they've just found your blood sugar values are amazing. In fact, my blood sugar values have pretty much looked like a non-diabetic. They've just looked like a regular person's blood sugar values, just because the technology has just been that good at doing what it does.
And part of the reason is because if you have a human in the loop, they're only going to do it occasionally.
Yeah.
And if you have a device, it has nothing better to do with its time.
Yeah, basically. So like I get a new value from the glucose sensor every 5 minutes. So every 5 minutes, it just runs the calculations. It's just like, hey, is everything still going as expected? If not, give you more or less insulin. And it just does that 24 hours a day.
It's very strange to me. I've developed medical devices, so I have some perspective from the medical device manufacturers, but also I'm very sympathetic to, hey, I would like a product that improves my quality of life, and you're not creating it.
Because you're too much of a wimp.
Well, yeah, that's the thing, is this market exists, and I do know that what those devices are doing takes you from, as you said, one level of safety to another level of safety, which means a lot more documentation, a lot more verification, probably a 510K clinical, whatever. But the market exists. So, and there's lots of much, for lack of a better word, stupider medical devices that people put through studies that go for a long time. So it's very strange to me that they didn't look at this before and say, this is a good market. And even the monitoring devices, I mean, a glucose monitoring device, yes, you've added the human in the loop to self-inject glucose or whatever, but if that screws up, there's a lawsuit there no matter what, too. I mean, But
that's user error.
Not if the thing is reporting the wrong value.
Oh, that's true, but it's easier to report the right value. I mean, that's a almost provable case.
Yeah, and I mean, like, I've had it mess up where I've gone low and all my things say, oh, nope, you're perfectly normal. And I've had gone high when it said I'm perfectly normal. And, there's, mistakes happen and bodies are weird. And it's really kind of impossible to get it perfect every single time. But at the same time, this is the only, like, disease and medicine related things I've ever heard of where basically I'm given a blank check and a giant bottle of medicine and they say, take whatever you need. Good luck calculating it. Here's some basic ideas on how to get started. Here's what you do if it goes bad. By the way, you will likely overdose, and here's how to counteract that. And, it's like, you don't really do this with a lot of other diseases. It's not 2 pills a day, twice a day. This is just basically like a bottle, and I don't know, figure out how much food you ate and take that much insulin for it. And turns out people aren't always really great at calculating those, especially if they're not really science oriented. So even like taking part of the equations out and putting them on a computer really helps dramatically.
That makes a lot of sense to me. And I have a question here about open source and how it can be hard for non-technical folks to get used to. But then I also remember my mom making graphs and how bad she was at it. How hard is it to use the OpenAPS?
It depends. There's multiple types of artificial pancreas system, which is what the APS is. There's several different types. It depends on which one you're using, which ecosystem you're in. So essentially like which pump and glucose sensor and phone you have. Depends on like how easy it will be in the end. LoopKit is the one that's on iOS. It's compatible with a variety of different pumps. It's usually pretty easy. Has a really nice user interface. All the calculations are done on the phone. It just uses Bluetooth and a separate little device to talk to the pumps, and it's pretty easy. There's also AndroidAPS. It's also fairly easy. It's the one I use now. OpenAPS was a little bit more difficult just because it was basically a Linux device, and it ran all the algorithms on it. But it also meant like I didn't have to do much. It just kind of like casually ran in the background, and I didn't always have to have like my phone all the time for it. It was a little bit more complicated just because you had to like SSH into it if something went wrong and figure out kind of what happened. But they say on several of the manuals, just like you don't have to be necessarily technical or a programmer or anything. You just have to be willing to kind of learn the time to, or spend the time to work with the device. So like, kind of all technology, you need to kind of sit down and read the instruction manual. With anything with a bunch of variables, you kind of have to take the time to configure it. So like the amount of insulin I need per carb is different for me than it is for like you two. And so like your body's kind of automatically adjust for whatever you eat. Mine doesn't. And it has changed over time too. So it's, periodically I kind of have to revisit, like, is this the same value I think it should be? If every time I'm going low most of the time, it probably means my math is wrong. So I have to kind of like go back and tinker with it. So it's like you will have that problem whether you have the pancreas system or not.
Right.
And, the pancreas system is kind of nice because there's ways to figure out how off your values are over time. So it just does the statistics to see like, oh, hey, you're taking 5 units per, this many carbs right now. We think that's really wrong. You should be doing like 4 units per this many carbs. And
can you imagine a medical company telling you that? Medical devices company?
No.
Because that's too close to medical advice.
Well, yeah.
But it shouldn't
but
be.
But pacemakers exist. They're autonomous.
Yeah.
And and defibrillators, implantable defibrillators exist. So there's precedent for automatic autonomous devices that are managing life-critical systems.
But not ones that learn.
But the other thing is I can always override something. So if I'm going low and the system's not really taking care of it, I can always stop it and take care of it too. So it's not like, the pancreas devices, they're external. Like I keep one in a little pouch and I wear it on my belt loops or in dress pockets or whatever. But, I can always turn it off. I can always override things. I can always tell it like, hey, quit doing the automated looping system. So it's just back to manual efforts or whatever too. So, it's not like it's inside me and I can't ever touch it.
Right.
Whereas like some of the pacemakers are.
Were you involved with the development of any of the artificial pancreases?
I was not. I have fixed a couple bugs and I started working on a easy to install system for OpenAPS when I was using it more often. So it's really like log into the device, update, all your Linux packages, install this GitHub repo, run the install scripts. And I kind of thought like, this is stuff a person doesn't really have to do. It's like something a computer could you just plug it in and, let a program do that for you. And so I started writing something like that, kind of got pulled away from work and a bunch of other mental health things. And I kind of stopped working on it. But and then the devices you use on OpenAPS are a lot harder to find now. So I just haven't went back to working on that. So I haven't really worked on like the core of the algorithms or the apps or anything, but I would love to. I have started looking at AndroidAPS's bugs and pondered if I could fix any of them, but I haven't contributed there yet.
So what does the hardware look like? Is this existing hardware that's been jailbroken, for lack of a better word, or is there's a unit that's an open source hardware unit that?
Yeah, good question.
Or is it just a phone app?
Or all three?
Or multiple combinations of all the above. So OpenAPS was, when I first started it, it was an Intel Edison chip. So it was a system on chip. Yeah, Linux. You just kind of SSH'd in and all the things. It was attached to either 430 megahertz transmitter board or 900 megahertz transmitter board to talk to whatever kind of pump you were using. And so it was kind of small, fairly easy to tote around. Intel quit making those chips. And then eventually the company that made the transmitter boards went out of business. And so we can blame the pandemic for that. But the next one is, it's called a Reilly Link. So instead of being like Linux on it, it's just a simple device that accepts Bluetooth and transmits over 400 or 900 megahertz. So it's essentially just kind of like a bridge. So it expects your phone really to tell it what to say to the pumps, and it will just like send those signals. Reilly Link, it's, I don't know, like 1 inch by a couple inches, and it was like half an inch thick. So not too bad. Also like really easy to carry around, like Tic Tac container sized. And the one I use now, it's called an Orange Link. So it's actually in a container that's specifically the size of an AirPods case to like be able to be carried in like cases made for AirPods. So it's, still pretty small, really easy. All of these are open source, so you can actually like go online and see how they made the boards for them. The Reilly Link and I think Orange Link is open source too. But yeah, you can just like go get the schematics, learn how to do them. You could even build them yourselves if you really wanted to. And then as for the apps on the phones that talk to that device, they're all open source as well. So LoopKit for iOS is loopkit.github.io. There's AndroidAPS. That's pretty easily searchable. And then OpenAPS, I think, is just openaps.org. And you can just go look at the code, read all the documentation. There's tons and tons and tons of documentation. So it's not just like install it, go figure it out yourself. Like they guide people through all the settings and how to configure them for your pumps and your sensors and everything.
Because this is better, because this is actually safer.
Yeah. And like I said, it's not perfect. I still have my days where things go like drastically wrong. But there's so much fewer and farther between, and it's more accurate. And it just does tiny little changes over time instead of me doing like a large change after every meal. And it's just more accurate that way.
In the beginning, you talked about lots of languages, different languages you work with. Why haven't you specialized? That is a terrible question. Let me try that again. What languages do you like best, and why haven't you specialized? Dang it. I guess I'm going to go with that.
I'm just picturing now like, Sarah, you haven't stuck to one language. What's wrong with you?
That's not what I mean.
I know. It's because you're not the first person to ask this. It's just like it just sounds funny that way,
I mean, I don't think it's that weird. I speak C and Python fluently, and C++ with a little bit of a C accent, and I've done awk and basic, so much basic. MATLAB. I mean, you take great pride in speaking multiple languages, multiple programming languages. Do you speak multiple speaking languages?
That's okay. I was going to say human languages, so that's not much better.
Yeah, that works. I took French in high school and was pretty good, but that was like 20 years ago, and I've gotten considerably worse at French. I started learning sign language and then stopped, and then kind of relearned it and then stopped, and I'm kind of relearning it again. So those might be, besides English, the other two languages I've kind of learned for the human side. But yeah, for computers, it didn't start out me going, I'm going to learn all these languages and I'm not going to pick one. I'm just going to like do a new language at every single job I land at. It kind of sort of happened by accident, I guess, in that like I learned BASIC when I was a kid, and then computers got better. I learned Visual Basic when that came out. Mm-hmm. I think my first college class was C++ and then Java after that. And then I was learning PHP on the side for something. I forgot what it was. And just kind of over time, like these little dashes of extra languages got blended into me. And then like when I started getting jobs after college, one of the first places I was at was a bank, and they kind of did this rotation program. So I tried different teams to figure out like which one I wanted to be permanently on. And like one of them was in C#, and then the next one did some Java stuff. And then I think the next one was, I think it was going to be C# too. And then I ended up just moving jobs over to a PHP job. And I don't know, it's kind of interesting because I never intended to just say, like, I'm going to do a different language at every job. But I think it's meant seeing so many different ways to do things and thinking through problems in like so many different types of ecosystems that I think it's made me a better developer. Just because I have this like wide variety of knowledge on how things are done. And so if you just throw me into a project, I feel like I usually have like a really good range of ways of solving problems. And also just because I've been in so many different languages over the years, I can probably get tossed into most anything and hit the ground running with little effort. Like, I'm not necessarily an expert in any of these languages, but I know enough that I have an idea of what I'm doing and an idea of where to go to find answers to solve those kinds of problems in that language. So it's like I don't always know how to do everything in Python for like my day job, but I know where to look to find those kinds of answers.
Is it Stack Overflow?
I mean, that's some of it, but also just, dabbling in Python over the years means I kind of know like what kinds of packages I might need to look for to do different things. Or, I know the different types of, like what's kind of built into the language, what's not built into the language. And just can kind of poke around either Python's documentation or, like ask the right question on Stack Overflow, I guess. But just also search through other types of materials and kind of understand, like what do I need to write myself? What can I look in the library for? What's built in the language? Or do I need to kind of pick and choose from different places to kind of assemble a solution?
Which language would you want to learn more thoroughly?
Oh, gosh. That's a good question. I think possibly something like Haskell, just because I've dabbled in it before in a school project. And then I did a job where I learned Scala, but I wasn't like particularly great at it. But it's such a different way of thinking about problems that I really would like to get a lot better at it.
It's one of the things that learning multiple languages, I think, did for me. I don't know that many, and ones I used to know I've completely forgotten. But
Pascal.
But like a recent one I had to do a lot of work with was Swift, which is a more modern language, and it's very opinionated about certain things, and it has, built-in language features that kind of guide you toward a certain way of thinking about structuring your program. But having learned that and seeing those things, it's kind of easy going back to like C or something to say, oh, this is something I can adapt. This is a design pattern or kind of a way of structuring code that I can adapt to this other language. It doesn't really have the feature to do it, and it just feels like each language has its own kind of opinions about a lot of things, whether it be design patterns or how to deal with memory. And those aren't necessarily things that are siloed. Once you've learned them in one language, you can kind of like, oh, I should be more object-oriented in this other language, even if it's not an object-oriented language.
Is there anything from Swift you can use as an example? Was it messages, I think you mentioned at some point? Or contracts?
No, I'm trying to think. There's ways of doing early exit from functions and doing what are called cards. There's kind of the whole function pointery thing about having, you can't really do lambdas in C, but you can do callbacks and stuff like that. Kind of making things more asynchronous with callbacks and things. That's probably the first thing that comes to mind. There's other things. And Swift is object-oriented, so it's closer to C++ than C. But
object-oriented, there's no reason why C can't be.
Yeah, you have to build the machinery.
You don't even have to use function pointers. You just have to think about things as objects.
Yeah.
And try to corral them into their own little kingdoms.
So do you find yourself doing that? Like, oh, there's this Java language feature, or there's this Java-ish thing, but I'm writing in I don't know, Python and...
Yeah, I do that from time to time. Like we're in a project at work right now, and it keeps reminding me of like a whole bunch of problems I solved in a C# web app several years ago. And I keep thinking like, oh yeah, we did it this one way. I wonder, should like actually try and do it that way here? The problem's really close enough that I should try to solve them the same way. And, since it's Python in this job and C# in that one, I'm trying to think like, what are the equivalents of some of these things? Is it like as efficient and tidy to do them a certain way? We kind of wrote some like terribly hacky ways of solving the problem in C#, but I also think there were creative solutions, and so it makes me wonder, like what's out there? Does Python have any of these kinds of things similarly built in a library somewhere? Could I reinvent the solution? And yeah, and it's one of those kinds of things. Like I think if you were like an expert in one language and then you were tossed into another one, you might actually struggle a bit. Whereas I've kind of done enough of these languages, I'm not really like as nervous about jumping around on a regular basis as I think some people are.
I know some people are. I am not as nervous as I used to be. Mm-hmm. I mean, a client asked me to do something in C# and I was like, okay, fine.
The only thing I'd be nervous about was being tossed into a functional language, because I don't understand that stuff at all. But regular stuff, fine. They're all similar.
Yeah, and I do think one of the hardest things is the paradigm shifts. Like you're thinking about a problem in a different way. It's like if you're writing something in Perl and you're like, oh, I'm going to write Haskell now. It's like two totally different ways of thinking. And that's a lot harder, I think, than just jumping to a language that's similar, which is why I think like C, C++, C#, Java, PHP, all those are similar enough. You can kind of bounce back and forth between them with little like friction,
Yes, but if you go from Python back to C, suddenly you have no ability to hit the semicolon key again.
Yes, that's also a little different.
Yes, I took a 2-year-long Python break and came back to C and for a client, and it was a mess for a while.
If you were starting a project from scratch, is there a language you would choose?
I don't know. I'm very much the choose the right tool for the job kind of person. So I don't know that I'd want to sit down and just say like, oh, I know this one the best. That's what I should do it in. I would probably try to think like, what does a language work really well in? Where's the, ecosystem of like web frameworks or whatever you need around to help you with that? I also would probably think like, if I'm on a team and there's a bunch of people that have different types of knowledge, where that like, what might be the least friction to get any of them up and going in it too?
Yes, I say that with people who want to do C++ and embedded. I'm like, yes, absolutely, as long as your whole team is writing it. Mm-hmm. But if you have one person writing C++ and 4 people writing C, everybody is going to be unhappy.
Yeah, that goes for anything.
It goes for any language. Yeah, those two are just compatible.
I mean, I've often been on projects where it's a big legacy project. It's in C or C++, and then people come in and want to, oh, we should rewrite this and blah, blah, blah. We're new people on the team. It's like, well, dude, you don't know what you're asking.
Not only are you rewriting all of the bugs we've finally
but none
fixed,
of us know how to use this.
You're asking us to do something we don't know how to do.
Yeah.
That's not always trivial to learn. Is there a language you know that it was easier to learn than others?
Oh, gosh. The problem is once you've learned so many, the new ones just absorb a lot quicker.
The last one you learned is probably the easiest.
Yeah. And, it's hard to judge at this point, because I think the first big transition was like basic to C++. And that kind of broke my brain in the beginning, just because I'm like, whoa, this is weird. I picked it up. It turned out not to be like particularly hard, just different, and then, Java wasn't too hard of a transition after that. Neither was PHP. But then, like I had a school project that was in Haskell, and that broke my brain for a little bit. What else? Yeah, and then like when I took the job that did some stuff in Scala, it's just like, well, I had to kind of remember some parts of Haskell, but it didn't break my brain nearly as much the second time. And
having seen Haskell.
Yeah. And like Rust, I haven't used it, but I took a workshop on it. And, once they explained like, oh, basically think C++, but like a lot safer with types and memory management and all that, like, it broke my brain kind of in the little beginning, but it didn't, after like 30 minutes, like, okay, this actually makes a lot of sense. And, if I wanted to, I probably could sit down and, a little bit more, maybe reading up on it. I could probably like get working in it pretty quickly. So it's I don't know. I don't.
Are there any languages you hate? Not hate necessarily, but if a project comes up, it's like, oh, this again.
I would program in Fortran again if it came up to it. That's so sad. I'm sorry, Sarah. Project languages you hate, not languages that I should but don't.
Periodically, I kick myself when I land in something like JavaScript, but like on the server side, just because I tend to think in things like, oh, you start here and you run all these commands in order. And JavaScript's like, nah, I'm going to parallelize everything for you, which is, a cool feature. But if I kind of have to like turn off one side of my brain and turn on the other side of my brain again and think like, okay, when nothing works right, when I have like a bunch of empty variables in different places because the parallelization hasn't filled in the values for those yet, I kind of like always have to kind of kick and scream just because I'm like, I have to rewrite this in a different order and doing like asynchronous waits and stuff like that. And it's not bad. I just always have to like kick myself because I end up in the same problems every time. The other thing is Rails. I think it's really cool, but there's a lot of like magic that just sort of happens. And I'm one of those people that really wants to understand what I'm doing. And so sometimes, like, if I land into a problem and then I go find the solution for it, and the solution is just like, oh, add this one line. And I'm like, I don't get why you add that line and how this line should work. Because there's a lot of cool stuff that Ruby's doing, but it's kind of behind closed curtains and you can't really tell what's happening. So it's not that I hate these. It's just every time I land in them, I find myself just kind of scratching my head a little bit more than I normally do.
Code thesaurus. What's that?
Good question. It's an idea I came up with several years ago, hopefully to solve some of my polyglot problems, which is, this was like 2016 or something like that, where I was on a Slack community and somebody had just randomly DM'd me and be just like, hey, Sarah, could you help me with this Ruby problem I have? And I'm like, I don't actually know Ruby, but maybe I could try and help you find the problem. And she showed it to me and I kind of looked at it and I'm like, I'm pretty sure your problem, is on this one particular line in this spot, but I don't know what the right answer is. It's like, I know how I would do it in this other language, but I don't know how I would do it in this. And I kept like trying to dig. I couldn't word it correctly on Stack Overflow to get an answer. I couldn't really find it in the Ruby documentation. I couldn't really find it, in several different places. And I'm just like, why can't I just look at these side by side? Like the language I know and the language I don't know side by side. And I kind of thought like somebody's built this already, right? And so I go looking around the internet. Couldn't really find anything exactly like this. There's cool things like Rosetta Code, and it shows you like how to solve problems in different languages, but it doesn't let you compare languages themselves side by side. And people sometimes solve the problems differently depending on the language. And so I couldn't find this exact thing. And so eventually kind of came to terms like, I'm probably going to have to be the one to build this thing. And so, I call it the Polyglot Developer Reference Tool. And so you can choose a concept like functions or file input output or strings or something, and then choose two languages. And you can actually look at how to do a whole bunch of things in that concept side by side in these two languages.
That's pretty cool.
How many languages do you support now?
I think we're up to 21.
Should there be 21 languages? Sorry.
I don't know. Let's take the best features from all of them and make this 22nd.
20, 21, 22. Oh, 22 languages. And I know there's a couple PRs to add some new ones in. So I think there's 2 more that are going to get added soon.
And so I can go there and say, what are the conditionals like in a language I know, like C, and what would they look like in a language I don't know, like Haskell?
Yes. And so you can look up ifs and loops and all that on, I think we call it control structures in there. So it's like when you pull that up, it's just like, how would you do an if? How would you do an else if? How would you do a switch or a ternary conditional? While loops, do until, do whiles for each loops. And sometimes languages don't have these. So we do have the built-in concept of, specifying like, hey, this one language doesn't actually know how to do this thing.
This is really cool. This would be very handy when you're learning a new language, or if you're well-versed in another language and you have to use a different one. Yeah. Just because there's a bunch of times, like it's like when you're speaking language, like when you're learning a spoken language, initially you spend a lot of time translating in your head. Like, okay, I'm speaking English in my mind, and now what's the French thing? And you construct that. I mean, that's not really being fluent, but the same thing happens, I think, with programming languages. It's like, okay, I think in C, and so if I'm in Python, then a for loop that I would have in C to do, and sometimes that's not the best way to do things, but it's the way to get started with accomplishing.
Yeah, it's how we learn.
Yeah.
So I think of it as like a good one, like a reference tool. So like if you just like, oh shoot, I'm working in Java, string capitalized, lowercase, you can quickly go find it out. But also can be that learning tool. Like I know C++, Rust sounds really cool. I want to learn Rust. Like you could read a book, or you could kind of like skim code thesaurus for C++ and Rust side by side and get a kind of a decent idea of kind of how it works. Like you wouldn't know all the like ins and outs of Rust just because it does kind of change some stuff around, but you could at least see like, oh, hey, here's kind of like the major differences between them. And then, yeah, sure, maybe like taking some other method of learning, you could kind of use this as a reference tool.
And it's a reference. It's a quick reference. It's not an encyclopedia.
Yeah. I try to make the distinction, like it doesn't teach you how to program. So you kind of have to go in knowing like what kind of loop do you want for a particular situation. Like this won't tell you that, but it will tell you, like if you know specifically you want to do until loop, here's how to do it in this language.
Is this this is obviously not automated. So this is all hand built by contributors and yourself?
Yeah. So I built a lot of the foundational frameworks on it. I am extremely lucky to have had, I think, like 120 contributors to this so far, just over the 3 years I think it's been public.
I can't find pointers.
Oh, I don't have pointers in there. Memory management and kind of memory stuff is one of the concepts I want to add in the near future.
Yeah, that'll be fun in Swift and Rust with their various unsafe and
yeah.
No, it's going to be interesting to see how this.
I mean, that's going to be a very different thing between languages.
The truth is, very few of these have pointers.
Yeah.
Yeah, I noticed C wasn't.
Well, there's also like some of them use references for things, and then there's like Java where you if you ask if some object is equal to another, it's not like are the things inside equal. They're it's the memory address equal, and so it's kind of hidden a little bit. So like if you try to compare two strings, it's really like comparing, is this the same string object? And like, that's not what you want. So it's some of the like confusions around that, like how languages, like how do you look at memory things? How do you create new objects if you want? Or, like, then there's like the C way, it's just like, allocate me this much space in memory, please. Not a lot of languages, or at least not a lot of the like really modern languages have that, but some of the, I guess, more classic traditional languages do have more of that.
Ooh, Objective-C. You have any plans to remove languages like Objective-C?
No, and that's one of the things is like one of the use cases I thought is what about Python 2 that's deprecated, but still it exists in so many places.
Yeah.
Like the conversion to Python 3 might be important. You can compare Python 2 to Python 3. And so it's like, and that's a perfect use case where you don't want to remove old things. But then I also thought like, well, what about if you're working like in you two work in the embedded space. Like what if you're using an old version of C or C++? Like you don't want, like, it's just the newest version's like what, C 20 and C++ 20, or I don't know if there's a newer one than that. But
unfortunately, the new one for C for most people is 99.
Yes.
Yeah.
No, there's a newer
quote
spec
unquote
for
new.
C, but
yeah, and it's like that's a perfect reason. Like that's been deprecated several times over, but it's still
good
like,
luck killing it.
You might, yeah, like it's still used, and so like I think it still needs to exist as a reference.
I mean, if you added anything to C99, where would you put the extra character? It would have to just be called 100 because you only have 3 characters there. C99. If you add one, all right, I'm not going to continue the bit because he's looking at me like I'm. Tell me about your First Robotics team.
So First Robotics is an international organization to kind of work with kids of all ages to teach them robotics and get them interested in STEM things. And I've been involved for, 11, 12 years now? So I started when I lived in Kansas City, and I mentored first Lego League team. And so they're elementary school kids that build Lego robots and then take them to competition. And the Lego robots basically like drive around the playing field and do different actions. Like you pick up little objects or you can hit buttons and something happens. And every time they do one of these things, they get certain points. And so the teams with the most points win, essentially. And then the middle school-ish group, it can be middle school to high school, is called First Tech Challenge. And so it's robots actually made of motors and metal and all those good things. But they're 18 inches by 18 inches. And they have to do also kind of a big variety of tasks, but they're on a 12-foot by 12-foot field. And then there's First Robotics Challenge, which is like high school only. And they're like 4-foot by 3-foot by 3-foot robots, I think. And they're on just like this massive field. It's something like 60 feet by 30 feet or something like that. I don't remember. It's huge. It's really cool because besides just being like a cool tech things and, hey, kids, you get to build robots. It's cool to see them like applying things that they learn in school. It's really easy to take a bunch of math and be like, where am I ever going to use this? And they actually do get to use math and like some of this robotic stuff, which is really nice. The second is it's fun. Code is sometimes hard to build a thing and then see like, yeah, this is the thing I made. You know, it's really virtual. So something like a mobile app's a little bit easier to kind of see what you're doing than like, I don't know, something that runs in the cloud. You know, you can't really hold that code nearly as easily. And so robotics is also good for showing kids like, hey, look, you can actually see the stuff you built. You can actually see the programming that's involved and how these robots respond to all these things. What's also great about the first system is they have what they call cooperation. And that's where basically like you're either usually like 2 or 3 teams versus 2 or 3 teams. And who is your teammate now might actually be your opponent in the next round or sometime in the future. And so you actually have to get used to like cooperating with people and understanding where they're really good at strategies or what the robot's particularly good at. But at the same time, also, you know, just like, oh, hey, I know the robot like does this particular thing really well. How can we strategize around doing something different or preventing them from doing that as well or something like that? So it's kind of cool to be in this environment where despite the competition, they are actively encouraged to be helping each other out in many different ways. And in fact, there's even awards for being like good players in this space. You know, like one competition I went to last year, there were a bunch of signs all over the place. And it was just like a robot tech support, basically. And just like, call or text this number if you're having trouble with your robot. Our team will come over and help you diagnose it. And I'm like, that's cool. That this one team just said, like, we're willing to help any team, whoever they are. And, if, we'll come in, we'll help you figure out what your problem is, help you solve it. And I'm like, that's just a cool way to see kids kind of, working with each other. And so I love it. It's great.
But right now, the competition's over and they haven't announced what's going on for next year. Is that right? It's November now.
Yeah. So first, Lego League is in kind of competition season, I'll call it. So their competitions are starting now or next month. First Tech Challenge is in competition season next month in January. So December and January. And then First Robotics Challenge, their rules are released in January. So they'll build through like January to March. So it kind of depends on which program you're in, whether you're actively building right now or not. And then I mentor specifically an FTC team. I'm in charge of our team here. And then I do a lot of like side involvement with FRC stuff. So I'll be helping them when their competition time starts too.
If someone is thinking about helping a first team, what should they know? What should they do first?
Yeah. So the easy way is you can go on firstinspires.org and find a team to work with in your area. There's probably a team that exists. They probably would love to have the extra help. You're always welcome to also start a team too. But if I were to suggest something to people, one thing I hear a lot is from technical people, oh, I don't know how to build robots. I don't know anything about wiring. I don't know anything about programming this stuff, things like that. And I really say that, one, the kids are learning, and you absolutely can go in and learn too. I feel like I'm constantly learning things all the time, either alongside the kids or I'm learning it really quickly ahead of time. And then I'm like turning around and trying to teach it to the kids, a week or two later. So definitely don't consider your knowledge level to be a limiting factor on being able to help kids. There's so many resources online too for teams that share like all their plans and how they build things and how they code things, to just like mentor support networks. There's forums that people post on. Reddit has several subreddits for the First Robotics stuff, and as well as some other competition teams. So all of that's out there. If you're not exactly a technical person, I've had a lot of like parents say like, that looks really nice. I would love to help out, but I'm not technical. And I'm like, there are so many teams that absolutely could just use a parent to help them do things around the side, take kids to competitions, or just be a scorekeeper, or manage some of the money stuff, or help them with presentations. Like there's so many skills in so many different areas, technical and not, that teams really could use. So if you think it's fun, if you want to help out, I definitely say, go see if you can find a team near you and absolutely help them. I love it. It's exhausting. I spend so many days a week with my teams, but it's wonderful to see them learn, to see them grow, to see them doing all these things that makes them happy, but also it makes me happy too. And I definitely have learned a lot through working with kids as well.
That was a very good advertisement for First.
Thank you.
I have never really gotten involved with. We judged one year
a long time ago.
But it was a long time ago, and we only went to one competition. So we really...
judging is so much fun. I love it.
It is a lot of fun.
I've even had some parents say, like, I could never be a judge. I would be too biased against my team. And I'm like, one, you're not judging your team. You're always opted out of that. But two, it is so cool to just talk to these teams, learn how they went about solving the problems they do, to learn about how their team works, to learn about all the different kids and what they're contributing to the different parts. I don't know. It's so much fun. I just love it. It fills me with great joy to be able to give them awards at the end of the competition, even if they're not my team.
Switching topics, as I looked at what you've done over the years, one of the things I noticed in your LinkedIn was that you've bounced around a bit. What are you looking for in your career?
Oh, that's a really good question. And every time like I've had to change jobs, it's always been kind of me asking myself that again. Just like, what do I want? Like how do I choose a job when I'm working on? I think some of it is I've been kind of this like code grunt where they're just like, Sarah, do this thing, like type. Here you go, And then I've had other times where it's just like, hi, we need this thing. We have not the foggiest idea how to do it. I'm like, cool, give me that. I will figure it out. I love solving weird and interesting problems, I think. So that's one of the things I tend to look for. I think if I, found myself without a job tomorrow, it's probably one of those, like, I don't want like yet another job where I'm building like a generic website. It's one of those things I want, like, where can I use my brain and solve interesting problems? And I do like working with people. I know it's that lovely programmer stereotype of like, I'm going to lock myself in the basement and shut all the windows and, bang on a computer for 6 hours alone. But I really do like working with others. So it's just like, I definitely look for like interesting teams and good people. And one of the things I really advocate for now is just good culture. So I've worked in jobs where, I'll put in like a pull request and they'll just like, why'd you write your code like that? And I'm just like, let's not do that anymore. That doesn't help me. That doesn't help you. So it's just like, do I have an industry I want to work in? Maybe there's like cool ones I think it would be fun to go for. But I think in some ways I've also been kind of burnt out on some things about the tech industry. Then I'm just kind of like, you know what? I'll settle for interesting challenges and good people more so than just like, oh, hey, stuff in space looks cool. Or, oh, hey, I want to learn machine learning stuff or whatever. That's kind of where I've settled right now. Ask me again in like 2 or 3 years and maybe that'll change. But
that's harder to look for. I mean, it's easier to say, these companies work on things that go to space. Most of them also work on missiles, so I'll have to make sure that only go to the right place. But but trying to find out if your coworkers are going to be fun, that's a much harder problem.
Yeah. And turns out people don't usually stick that in the job description. Just like, we have 4 great coworkers and one that could use a little work. Like they don't usually have that. I sure wish they did, but
I don't know that I would believe them. I think, and your coworkers will be super fun would be like one of those things that I look at the job rec and think, yeah, no, goodbye. That would just be too scary.
Depends on your definition of fun.
It does.
True.
Some people are too fun.
I mean, I've been endorsed on LinkedIn for puns, so I like to think that I'm a decent coworker, but
well, that's really an opening I want to go through, but I don't think you can ask people for puns just off the cuff because that seems rude.
Top 10 puns, go.
Oh gosh.
No, it's fine.
Wait, that's the embedded podcast. Looks like you all are wired today. This episode is giving you a lot of spark. Are these puns really feeling negative or positive? Do I sound like a really grounded guest?
Are you bored?
Bored.
Oh,
bored. Yeah, I can't. I did that. That's a auditory, not a visual reading pun.
Yeah. Thanks for the clarification. Clarifications make jokes better.
No, I'm clarifying myself because I was trying to figure out why I couldn't get it at first. It was an explanation of my stupidity, not the joke.
Thank you for chatting with us, Sarah. Is there anything you'd like to leave us with?
I'll come back to the mentoring thing. It's I've had some people always ask me just like, oh my gosh, you always are doing things. You're always doing the robotic stuff. Like how are you doing it? And, good helping out others just fills me with more energy. So it's like I put out this energy, but I get it back. And so I guess I would just say, look for where you're getting energy out of things and keep doing the things that fill you with that energy, even if you are expending a lot of it, because I do think the good things will keep filling you up.
Our guest has been Sarah Withee, polyglot software engineer, founder of Code Thesaurus, and first enthusiast. Oh, right. And she's a cyborg with the pancreas.
Thanks, Sarah.
Thank you for having me.
Thank you to Christopher for producing and co-hosting. Thank you to our Patreon listener Slack group for their help with building my computer. And of course, thank you for listening. You can always contact us at show@embedded.fm or hit the contact link on Embedded.fm. Now a quote to leave you with.
Now, t-shirts.
Oh, Christopher's right. We're going to put this at the very end. We're going to bury it at the very bottom of the show. Yes, t-shirts are on sale through the end of the year. There'll be a link in the show notes, or you can go to Teespring and maybe search Embedded. Christopher's going to try that now. It's not going to work. We'll make it work. But now a quote to leave you with. This is what happens when you search for pancreas for quote sources. From Jean Kerr. I'm tired of all this nonsense about beauty being only skin deep. That's deep enough. What do you want, an adorable pancreas?